Hello viewers, welcome to my channel. I'm Hasham Ali Khan. This is the last problem on minimization type. So 3 problems we have completed on maximization and 3 problems we are going to complete on minimization. Then we have to start the next type, that is mixed constraints. So in almost all the problems you have seen the procedure is same. But for maximization problems, slack variable will be added. And for minimization problems, surplus variable will be deducted and artificial variable will be added. And the optimality test will be different for both the problems, right? Now, these problems require a lot of practice. Simply watching the video will not at all be sufficient. Apart from watching the video, you have to practice all these problems. Now, I'm going to start the 6th problem. Before starting 6th problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Take the screenshot of the points, then I'll explain. Now, see the problem number 6. Solve by simplex. Minimize z is equal to 4x1 plus x2. Subject to constraints 3x1 plus 4x2 greater than equal to 20, x1 plus 5x2 greater than equal to 15, and x1 and x2 greater than equal to 0. So whenever the constraint is greater than equal to, you have to minus surplus variable and add the artificial variable. So this is the problem given. Minimize z 4x1 plus x2 subject to constraint 3x1 plus 4x2 greater than 20, x1 plus 5x2 greater than 15. And introducing the surplus variable and artificial variable, the standard form of LPP will be as follows. Objective function 4x1 plus x2. To this we add the surplus variable with 0 coefficient. So 0 into s1 plus 0 into s2 plus ma1 plus ma2. Already we have done this the same thing in the last 2 problems also. Now subject to constraints 3x1 plus 4x2 minus s1 plus a1. So this surplus and artificial variable have to be introduced in order to remove the inequality. This is the inequality and we are making it equation, right? Similarly, x1 plus 5x2 minus s2 plus a2 is equal to 15. So main purpose is to remove this inequality, we have to include the surplus variable and artificial variable. Now, an initial solution. After making this, all the non-negativity restriction says all the variables should be greater than or equal to 0. An initial solution will be obtained by taking x1 is equal to 0, x2 is equal to 0, s1 is equal to 0 and s2 is equal to 0. So that a1 is equal to 20, a2 is equal to 15. First simplex table does not require any calculation. Simply we take the coefficient. CJ stands for coefficient of objective function. So here x1, x2, s1, s2, a1, a2. The objective function here, the coefficient of 4x1, so x1 4, 1x2, x2 1, 0 s1, 0 s2, s1 0, s2 0, a1 m, a2 m, right? Similarly here also CJ value we have to take a1 is m, a2 is m, and a1 is equal to 20 and a2 is equal to 15. Now we take the coefficient of constraints. The first coefficient of constraint 3x1. So here I am taking 3, 4x2, s1 minus s1. So minus 1 we will take for s1. s1 is minus 1. And a1 is plus 1. a1 is plus 1. Remaining values 0. Second one. 1x1, so x1 is 1, 5x2, so x2 is 5, minus s2, so s2 is minus 1, and a2 is 1, a2 1, other values you take it as zeros, that's it. Now zj, multiply the cj value with the variable, m into 20, 20m, plus m into 15, 15m. So 20 plus 15, 35m. 35m. Here m into 3, 3m. m into 1, 1m. 3m plus 1m, 4m. m into 4, 4m, m into 5, 5m, total 9m, m into minus 1 and m into 0, m into 0 is 0, so m into minus 1 minus m, m into 0 is 0, m into minus 1 is minus m, m into 1 is m and m into 0 is 0, so m here also m. Now Cj minus Zj, 4 minus 4m, here 1 minus 9m, here 0 minus minus m, so minus into minus will become plus, here 0 minus minus m, so minus into minus will become plus, m minus m 0, m minus m 0. Now this is the index row elements. Optimality test says all the index row elements should be zeros and positive for minimization problem. For minimization problem, all the index row elements should be zeros and positive. If any negative is there, it is not optimum. We have to make the next table, right? The most negative element should be selected. Here we can't say which is the most negative because m is there. So we have to suppose. M means any cost which is more than the actual cost. What is the actual cost here? 4 and 1. This is the actual cost. So you can take any value which is greater than 4 and 1. You can take 5, 6, 7, 8, anything. But for easy calculation, I am taking let m is equal to 10. If I take m is equal to 10, 4 minus 4m, 4 minus 4 into 10, 4 minus 40 is equal to minus 36. Secondly, 1 minus 9m, 1 minus 9 into 10, 1 minus 90 is equal to minus 89. Now which is greater, which is the most negative? Minus 36 is most negative or minus 89 is most negative? Minus 89 is most negative. So 1 minus 9m, this is the entering variable for the next iteration. Which is the entering variable? x2. In the next table, x2 will enter. Which one will depart? It depends on minimum ratio. Solution value divided by intersectional limit. What is the solution value here? 20. Intersectional limit 4. So 20 divided by 4. 4 5s are 20. Here in the solution value 15. Intersectional element 5. 15 divided by 5. 5 3s are 15. So whichever is minimum, 3 is minimum. So which is the departing variable? A2. So in the next table, A2 departs and X2 will enter. Right? So this is the next table. So X2 enters and A2 departs. So here first one A1 remain as it is. In place of A2, now I am writing X2. The coefficient of A1, which one is departing here? A2 is departing. That means we don't require the column of A2. Whichever artificial variable is departed, no need to make the column. A2 is departing, so we are making only A1, right? So A1 coefficient is M, X2 coefficient is 1, right? Now we need values of entering variable. Entering variable. Entering variable is X2 is equal to values of departing variable. Departing variable divided by intersectional element. Right? Departing variable is what? A2. So what are the values of A2 here? 15, 1, 5, 0, minus 1 and 0. I am not taking the value of A2 because A2 is eliminated. Divided by intersectional element. What is the intersectional element here? 5. 5 is the intersectional element. Now 15 divided by 5. 5 3s are 15. This is 1 by 5. 5 divided by 5. 1. 0 divided by 5. 0. Minus 1 by 5. Here 0 by 5 is 0. So we got the values of the entering variable x2. So x2 values are 3, 1 by 5, 1, 0, minus 1 by 5 and 0. That's all. So we got the values of entering. Now we need values of A1. Values of A1 is equal to old values of A1 minus intersectional element into values of entering variable. Entering variable. Same formula what we have applied in every problem. So what are the values of A1? Old values of A1 are 20, then 3, 4, minus 1, 0 and 1. I am not taking 0 because A2 is eliminated. Minus, from this we subtract intersectional element of A1. Intersectional element is 4. So 4 into now values of entering variable. Entering variable values are 3, 1 by 5, then 1, then 0, then minus 1 by 5 and lastly 0 is equal to. Now see carefully. The only thing for doing these problems is the perfection of calculations. The student should be perfect in making this calculation, then only you can save the time. Otherwise it will be very much difficult. And the only alternative is you have to practice. So 4 3s are 12. 20 minus 12 is equal to 8. 3 minus 4 1s are 4, 4 by 5. So if we take the LCM 5, 5 3s are 15. 5 gets cancels one time, 1 into 4 is 4. So 15 minus 4, 11 by 5. Here 4 minus 4, 0. Minus 1 minus 0 is minus 1. 0 minus into minus will become plus. So 4 by 5. 1 minus 0 is 1. That's it. So we got all the values of A1. The values are 8, then 11 by 5, then next one 0, minus 1, 4 by 5 and lastly it is 1. That's all. So we have calculated the values of A1 and X2. Now we need ZJ value. M into 8, 8M. 1 into 3, 3. 8M plus 3. 8M plus 3. Here M into 11 by 5. So 11M divided by 5. Plus 1 into 1 by 5. Plus 1 by 5. So LCM 5, 11M plus 1. Don't add up 11 plus 1, 12. Because M is there. So write down same way. 11M plus 1 divided by 5. Right? Similarly, M into 0 is 0. 1 into 1 is 1. M into minus 1 is minus M. Because 1 into 0 is 0. M into 4 by 5. 4M by 5. 4M by 5. Plus into minus will be minus. 1 into 1 by 5 is 1 by 5. So LCM is 5. 4M minus 1. So 4M minus 1 divided by 5. Lastly, M minus 0 is M. Sorry. M into 1 is M. 1 into 0 is 0. So M. That's it. Now we need Cj minus Zj. So here 4. So 4 minus 11M plus 1 divided by 5. Here 1 minus 1, 0. 0 minus minus M will become plus M. Here 0 minus 4M minus 1 divided by 5. Here M minus M, 0. Right? Now the next thing is we have to find out. The most negative value. So here, most negative value. Optimality test says all the index row elements should be zeros and positive. If any negative value is there, then it is not optimum. We have to make another table. So most negative we have to select. Let M is equal to 10. So first case is 4 minus 11M plus 1. 11M plus 1 divided by 5. So 4 minus 11 into 10, 110. 110 plus 1, 111. 111 into 10 is 110 plus 1 divided by 5. It comes to minus 22.2. So 4 minus 22.2, it comes to minus 18.2. This is the value. Secondly, there it is 0 minus 4m minus 1 divided by 5. So 0 minus, I'll write down 0 minus 4 into 10, 40. 40 minus 1, 39. 39 divided by 5. It comes to 7.8. So minus 7.8. Now both the values are negative. One is 18.2, the other one is minus 7.8. Most negative is 18.2. 18.2 is 4 minus this one. So next table x1 will enter. So entering variable is x1. Now we need the departing variable. It depends on minimum ratio. So here 8 divided by 11 by 5 is equal to. Here 3 divided by 1 by 5. Now here we need the calculations. 8 divided by 11 by 5. This can be written as 8 into 5 by 11. That is equal to 8 5 is 40 by 11. 40 divided by 11 is equal to 3.64. Here 3 divided by 1 by 5, that is equal to 3 into 5 by 1. The 5 3 is a 15. So here we take 15. So in this minimum ratio, which is the minimum value, first is 3.64 and second one is 15. So 3.64 is minimum. So departing variable is A1. So in the next table, x1 will enter and A1 will depart. So in the simplex table 2, already we have completed. The entering variable will be x1 and the departing variable will be A1. Now we make the next table simplex table 3. So here simplex table 3, x1 enters and A1 departs like this, right? So I have taken, in place of A1 I have taken x1 and x2 as it is, whatever x2 is there, the same x2 I have taken here. Now the coefficient of objective function x1 is 4 and x2 is 1. Now first of all, we need the values of the entering variable. The values of entering variable x1 is values of departing variable divided by intersectional element. Departing variable is A1. The values of A1 are 8, 11 by 5, 0. So here you can see 8, 11 by 5, 0. Minus 1 and 4 by 5. We are not taking the values of A1 because A1 is departed. We don't have the column of A1, right? Divided by intersectional element of A1 is 11 by 5. So here I have taken 11 by 5 denominator, right? Now 8 divided by 11.5, 11 by 5. So if we multiply, it will become 5 by 11. So 8 into 5 by 11, 8 5 is 40 by 11. 11 by 5 divided by 11 by 5, 1. Then 0 divided by 11 by 5, 0. Minus 1 divided by 11 by 5. So minus 1 by 1 into 5 by 11. It will become minus 5 by 11. Similarly 4 by 5 divided by 11 by 5. So 4 by 5 into 5 by 11. So 5 will get cancelled. So remaining 4 by 11. Remaining is 4 by 11. So we got the values of the entering variable x1. So we note down the values of x1. First one is 40 by 11. Here I am writing 40 by 11. Then next one is 1. Next one is 0. Next minus 5 by 11. Next one 4 by 11. So we have taken the values of the entering variable x1. Now we need the values of x2. The values of x2 is equal to old values of x2 minus intersectional element into values of the entering variable. Same formula we are applying. Values of x2 is equal to old values of x2 minus. What are the old values of x2? 3, 1 by 5, 1. So here you can see 3, 1 by 5, 1. Then 0 and minus 1 by 5. 0 and minus 1 by 5. We are not taking the last 0 because A1 is eliminated. Minus. Intersectional element of this x2 is 1 by 5. So I have taken 1 by 5 in all the cases into values of the entering variable. Entering variable are 40 by 11, 1, then 0, then minus 5 by 11, and lastly 4 by 11. Now we have to simplify. So 3 minus 40 divided by 5 into 11 is 55. 5 into 11, 55. So 3 minus 40 by 55. If you take the LCM 55, so 55 into 3, you will get 165. Then 55 divided by 55, 1. 1 into 40, 40. 165 minus 40 divided by 55. So 125 by 55. It is divisible by 5. 5 11s are 55. And 125 divided by 5, 25. So finally 25 by 11. That is the value. 1 by 5 minus 1 by 5, 0. 1 minus 0 is 1. 0 minus into minus will become plus. 5 will get cancelled. So 1 by 11. Now minus 1 by 5 minus 4 by 55. 4 by 55. So LCM if you take 55. 5 how many times cuts 55? 11 times. 11 ones are 11. Minus 11. 55 divides 55 one time. 1 into 4 is 4. So minus 11 minus 4 is minus 15 by 55. It is divisible by 5. 5 3s are 15, 5 11s are 55. So minus 3 by 11. So these are the values of x2. Now I am taking the values of x2 here. That is 25 by 11. Second one is 0. Then next one is 1. 1 by 11. Last one minus 3 by 11. That's it. So we have completed all the values. Now we need the values of zj. Multiply the cj value with the variable. 4 into 40. 4 into 4. 4 for the 16. 160. 160 by 11 plus 25 by 11. 25 by 11. Denominator 1 into 25 by 11 is 25. So LCM if we take 11. So 160 plus 25 is 185 by 11. So here you can take 185 by 11. Here 4 ones are 4. 1 into 0 is 0. So 4. 4 zeros are 0. 1 into 1 is 1. Now here we have to carefully make the calculation. 4 into 5, 20. Minus 20 by 11. Minus 20 by 11. Plus 1 into 1 by 11 is 1 by 11. So LCM is 11. Minus 20 plus 1. So minus 19 by 11. The value is minus 19 by 11. Here 4 4s are 16 by 11. 16 by 11. Plus into minus will be minus. 1 into 3 by 11. So 3 by 11. So LCM is 11. So 16 minus 3, that is equal to 13 by 11. So here comes 13 by 11. So we have calculated all the values. Now Cj minus Zj. So 4 minus 4, 0. 1 minus 1, 0. 0 minus into minus 19 by 11. Minus into minus will become plus. So 19 by 11. Here 0 minus 13 by 11 is minus 13 by 11. Now one more table we require. Because all the values should be positive, 0 and positive, no negative should be there. If there is negative, then one more iteration we require. So here minus 13 by 11. So this is not the optimum solution. One more calculation we have to make. So here only one item is the negative. So this will be the entering variable in the next iteration. Next iteration S2 will enter. Now which value will depart? Again solution value divided by intersectional element. So here intersectional element is this one. Intersectional element is asterisk mark. Right? So 40 by 11 divided by 4 by 11. 40 by 11 divided by 4 by 11. We will write down like this. 40 by 11 divided by 4 by 11. So how much it will become? 40 by 11 into 11 by 4. So 11 gets cancelled. 4 ones are 4, 4 tens are 40. So here we get 10. Right? Here divided by minus, because minimum ratio should be positive. If it is negative, no need to calculate, because the solution value 25 by 11 divided by minus 3 by 11. The denominator should not be minus. So that's why we should not calculate minimum ratio. So only one minimum ratio, 10. So this will be the departing variable. The next iteration, next table, x1 will depart, and which one will enter? S2 will enter in the next table, right? Now, in place of x1, I am taking s2, and in place of x2 will remain same. This x2 will remain same, x1 will go away and s2 will come. So what is the coefficient of s2? 0. Coefficient of x2? 1. Now, again we have to calculate the values of the entering variable. We have to find out the value of the entering variable. Now, carefully you see, entering variable, which one is entering now? S2. So, S2 enters and X1 departs in this fourth table. So, values of entering variable is S2. Departing variable is X1, right? So, departing variable X1 values are 40 by 11, 1, 0, minus 5 by 11, and lastly 4 by 11. See here, when S2 is entering and X1 is departing, so divided by intersectional element of X1, intersectional element is 4 by 11, 4 by 11, so divided by 4 by 11. Now carefully, 40 by 11 into 11 by 4, it comes to 40 by 4, it comes to 10. Then 1 divided by 4 by 11, so 1 by 1 into 11 by 4, that is equal to 11 by 4. 0 divided by 4 by 11 is 0. Minus 5 by 11 into 11 by 4, that is equal to minus 5 by 4. Here last one, 4 by 11 divided by 4 by 11, it is 1. So we got the values of the entering variable. Entering variable is S2. So S2 values are 10, then 11 by 4, then we have 0, then we have minus 5 by 4, and lastly we have 1. That's all. Now we need the values of x2. The values of x2 we have to calculate now. So here I am going to calculate the values of x2. See here. Old values of x2. What are the old values of x2 here? 25 by 11, then 0, 1, 1 by 11, minus 3 by 11. These are the old values of x2. Minus intersectional element. What is the intersectional element? Minus 3 by 11. Minus 3 by 11. Into values of the entering variable. Entering variable values are, that is 10, 11 by 4, 0, minus 5 by 4, and lastly it is 1. That's it. Now calculations. 25 by 11, minus into minus will become plus. 3 into 10, 30 by 11. That comes to 30, 40, 55 by 11. So 11 5s are 55. 0 minus. So minus into minus will become plus. 3, 11 will get cancelled. 3 by 4. 1 minus 0, 1. Here 1 by 11, minus into minus will become plus. So 3 into 5. No, here minus into minus will become plus. Plus into minus will be minus. 3 into 5 is 15. 11 into 4 is 44. So LCM is 44. 11 how many times cuts 44? 4 times. 4 ones are 4. 44 cuts 44 one time. 1 into 15 is 15. So 4 minus 15 is minus 11 by 44. Minus 1 by 4. Minus 1 by 4. Then next one. Minus 3 by 11. Minus into minus plus 3 by 11. So minus 3 by 11 plus 3 by 11. It will become 0. So we got the new values of x2. That is 5. Here it is 5. Then 3 by 4. Next 1. Here minus 1 by 4. And last one is 0. That's all. So we have calculated all the values. Now zj value we have to calculate. 0 into 10 is 0. 1 into 5 is 5. So here comes 5. 0 into 11 by 4 is 0. Right? 1 into 3 by 4 is 3 by 4. 0 into 0, 0. 1 into 1 is 1. 0 into minus 5 by 4 is 0. 1 into minus 1 by 4 is minus 1 by 4. Then 0 ones are 0. 1 into 0 is 0. That's all. So we have calculated all the zj value. Now cj minus zj. What is the cj value? 4. 4 minus 3 by 4. If we take LCM 4, 1 4 times. 4 4s are 16. Minus 4 1 time. 1 3 is a 3. So it will become 13 by 4. Here comes 13 by 4. 1 minus 1, 0. 0 minus minus 1. So it will become plus. Minus into minus will become plus. 0. 0 and minus 0 is 0. So we have completed the index row elements. All the index row elements are zeros and positive. We don't have any negative element in this index row. So we have reached the optimum solution. So after completing this, conclusion. Since all index row elements are zeros and positive, so we reached the optimum solution. The optimum solution is x1 is equal to 0. We don't have x1 here. In the solution, we don't have x1. So x1 is equal to 0. And x2 is equal to 5. x2 is equal to 5. And minimum z is equal to 5. Minimum cost is 5. That's all. So this is the end of problem number 6. So 3 problems I have completed on maximization, 3 problems on minimization. Right? The next 3 problems we will solve on mixed constraints. Mixed constraints means some constraints are less than equal to type and some constraints are greater than equal to type. And some constraint may be in equation. So there you have to be very careful, recall, because for less than equal to type, we have to add the slack variable. For greater than equal to type, we have to deduct the surplus variable and add the artificial variable. If it is already in equation, only artificial variable is required. That we'll do it in the next problem, inshallah.